Okay, the topics here is limits at infinity. So let's do first example 9. So this is the limit of a rational function as x goes to infinity. In this case, there's a trick that we always use. All you do, look at the denominator and just pick the term with the highest degree. Since the term with the highest degree is 3x squared, so we're going to divide by x squared. In other words, we're going to ignore the 3 and just divide by x squared, the top and the bottom. Right, so let's divide the numerator and the denominator by x squared. So this is going to be equal limit 6x squared over x squared minus 2x over x squared plus 5 over x squared. So we divide the whole numerator by x squared. I just save one step. So this is what we mean with dividing by x squared. Same thing, the denominator we need to divide by x squared. So plus x over x squared minus 1 over x squared as x approach positive infinity. Now this is equal to, so we need to simplify. If we can simplify, so limit as x approach infinity of, first this x squared goes with this x squared, so you'll get 6, do this line here. Now 1x goes with 1x, so you'll have minus 2 over x plus 5 over x squared. Now same thing, simplify x squared with x squared, you get 3, plus simplify 1x with 1x, you get plus 1 over x, and then minus 1 over x squared as x approach infinity. Now remember, we did in the previous examples where this kind of limits, 2 over x is going to approach 0. This is going to approach 0. These are easy limits. This is going to approach 0, and this is going to approach 0. In other words, this is going to be equal 6 minus 0 plus 0 over 3 plus 0 minus 0, which is 6 over 3, which is 2. So remember, so in other words, every time, this is just like, I don't know if you notice this, but every time you have a degree of the numerator is equal to degree of the denominator, in this example both of them are 2, you're always going to get the coefficients divided by each other. In other words, you're going to get the 6 over 3, which is 2, but you still have to show your work. Alright, for example 3, now this is another different example from example 9, because the degree of the top is 3 and the degree of the bottom is smaller than the degree of the bottom. So we're going to use the same method. This is the same thing as a limit, so we're going to divide by x7. See, so always look at the degree, the highest degree, the term with the highest degree from the denominator. So we're going to divide both by x to 7. So this is a limit 3x cubed over x to the 7 plus 2x over x to the 7 minus 1 over x to the 7, everything divided by 4x to the 7 over x to the 7 minus x squared over x to the 7 plus 3 over x to the 7 as x approaching negative infinity. Now same thing, we're going to simplify stuff. So x3 goes with x3, so you'll have limit of 3 over x4 plus, and then 1x goes from both, so you get 2 over x6 minus 1 over x to the 7, everything divided by, same thing, x7 goes with x7, you get 4 minus x squared goes with x squared, you'll have 1 over x5 plus 3 x7 as x approach negative infinity. Now same thing, we're going to use the previous limits. This is going to approach 0, 0, 0, 0, and then 0. So this is going to be 0 plus 0 minus 0 over 4 minus 0 plus 0, which is equal to 0 over 4, which is equal to 0. So again, here you need to notice every time the degree of the numerator is smaller than the degree of the denominator, you're always going to get a 0, but you still have to show your work. Now for example 11, now this is another different example. There's only 3 types. Now the degree of the numerator is bigger. See, the degree of numerator is 6, the degree of the denominator is 4. But we're going to use still the same method. So we're going to divide both by x to the 4th, right? So this is equal limit x6 over x4 plus x cubed over x4 plus x over x4, everything divided by x4 over x4 plus 2x over x4 minus 1 over x4 as x approach infinity. Again, we need to simplify. By the way, the reason why we can simplify, we know x is not equal 0. So you could simplify the x's, or x4 by x4. You can simplify. X is not 0. X goes to infinity means x is a large number. It's not equal to 0. So this is equal to limit of x4 by x4. We're going to get x squared. Simplify x cubed with x cubed, you get 1 over x. Simplify x with x, you get 1 over x cubed. Everything divided by x4 by x4, you get 1. And then x with x, you get 2 over x cubed. And then 1 over minus 1 over x4 as x approach positive infinity. Now again, this goes to 0, this goes to 0, this goes to 0, this goes to 0. So this is the same thing as the limit of x squared over 1, which is just x squared, as x approach infinity. Now, this is pretty easy. Why? Because as x get larger or larger with positive values, if you square it, it's still getting larger. So this is equal to infinity. That's it for this example. And then example 11, you're always going to get either positive infinity or negative infinity. It depended what you got left of. So we'll do next 2 examples just to show you the difference between the two. Alright, so that's it.